Flack math! Give me some math and I'll give you some flack. Flack math!
So our homework is problem set 36, 38, and then I'm going to put the practice test up here, but it's technically not due until like 2 weeks from today, like when that test is. Okay, but extra credit, it's due. I'll give you 10 points if you get this done by Thursday, or online learners, if you get it done before I upload the video on Friday, then I'll give you 10 points. But if you get it done by Tuesday, a week from now, then I'll give you 5 points, and we're gonna go over it on Tuesday. Okay? I'm gonna get a new marker for the day. You should just have a bag of markers ready to give me. Look at all these black markers. They're the first ones to go. All right, so we're gonna do lesson 35. Okay, and we're going to talk more about the distributive property. We've talked a little bit about it. There goes my cap. So basically, the distributive property changes a product to a sum. Okay? So you got two things multiplied together, 2a times this parenthesis. And then when you distribute, this is a product, something times something, but when you distribute, now you have a sum. Right? So this is a sum of two things. This is a product of two things. Well, to be fair, there's a sum of two things in there, so there are sums and products in both. But that's what the distributive property does. It changes a product to a sum. Okay? Now what we're going to do is one of my favorite things in the world, in the math world. Could be in the normal world too, like one of my favorite things. We started talking about factoring, and I told you this. So GCF, greatest common factor, the first step of factoring is to look for something you can take out of all the terms. Okay, so we did that on Thursday. Now what we're doing is the same kind of thing. So we're looking for the same thing we can take out of it. What can go into both of these terms? 2a, yeah, you kind of already knew it because that's where we started. So when you factor out a GCF, that is like reverse distributive property. Okay, what do they both have in common? They both have a 2 and they both have an a in common. So you take a 2a out and you're left with x plus c. Okay, remember going to the store, these two stores, and you want to buy the same thing from each store. What's left on the shelves? Just an x and just a c. Okay, so let's just start with another example. Example 2. Let's see if we can factor out the greatest common factor. Okay, so last time on Thursday we were just looking for the greatest common factor, but now we're factoring it out. So the first step is to figure out what the greatest common factor is. Can you guys see it? We don't have numbers, so we don't have to worry about that. How do you identify the greatest common literal factors? You guys remember doing this on Thursday? Nathan?
A to x1, not just x, and then int.
Okay, so what were you looking for when you found that?
The least.
Yeah, so you're looking for the smallest exponent. You're looking for, if you go to all three of these stores, what you can buy from each store to keep it fair between the stores, right? You can't buy 2 X's from this store because these guys only have 1 X to sell. Okay? So the easiest way to remember it is it's the smallest exponent. So when you're looking for literal factors, the letters, then you look for the smallest exponent. Okay? They all have A's, X's, and M's. So you're just looking for the smallest exponent of each. The smallest exponent of A is A squared. Smallest of X's is just an X. Smallest of M's, 2, 3, 2 is 2. Okay, so now you start shopping. So what's left on the shelf when you go to this store and buy this? What's left? An A and an X, right? You see that? Because if you distribute that, you'll end up with that. So see how it's the reverse distributive property? We're reversing the distributive property. Okay, what are you left with when you go to this store? Just an M. M to the first power, just an M. That's right. Okay, what about here?
A to x.
X what?
X. 3.
So you're getting an X, you're taking an X away from X squared, or X cubed, so you're left with X squared, and then M squared, you cleaned them out. They're out of stock of M's now. Okay? So it's okay to think that way, but really what you're doing is you're multiplying. So remember when you multiply, you add the exponents? Well, it's cool when you're doing this, and if you take a 2 out of 6, if you take a 2x out of 6x squared, what are you left with? All right, so that's the trap. See how we trapped you? Because you're still dividing. You're still dividing this out of this, but a cubed divided by a squared, you subtract the exponents. So you're not subtracting. You're still dividing, but when you subtract exponential expressions, when you divide exponential expressions, you subtract the exponents. Okay? So it's hard to switch gears and go, okay, this is still 3x, right? It's not, you're not subtracting 6 minus 2, you're only subtracting 2 minus 1. Okay? That's going to be a common mistake. So be aware of that mistake. Okay, good. Now, if you did this on a test or in your homework, you can easily check to make sure you got this right by just distributing it out, right? You just add the exponents and see if you get that, okay? Can you guys handle that? Let's try another one. Let's see if you can do this one on your own, okay? So let's factor. When I say find the GCF, all you have to do is this, okay? When I say factor the GCF, you have to do it all, okay? When I say factor 21, you don't say 3. You say 3 times 7. That's what it means to factor, okay? What times what equals that? All right, so this is the greatest common factor, but if you're going to factor this thing, you have to say what times what equals this, okay? Example 3, 4a to the third, b to the fourth, z cubed plus 2a squared b z to the fourth. So I want you to factor this. Factor out the GCF. Factor it. Try it on your paper. So keep working. I think all of you turned in your test. So if you guys want to do test corrections, you can get up to 10 points back, but I'll give you half credit back. So if you get an 80, and I'll give you a 90. If you do a Zoom call with me, I can give you up to 15 points back. So if you get a 70, instead of getting an 80, you get half of the 30 back that you missed, and you get an 85, okay? So if you do get below an 80, then it might be good to do a Zoom call with me just to make sure you guys are understanding this, okay? This is a critical class. Algebra is probably the most difficult math class that you will take. Now there's more advanced math classes, but relative to where you're at with your math, this jump into algebra is the most difficult, in my opinion. Okay? So don't give up. All right? If you're discouraged or anything, don't give up. We've got, what, 3 more weeks, 6 more days until Thanksgiving. And then we've got 4 more days after that until Christmas.
I think it's 2 weeks and then 3 weeks after Thanksgiving.
Is it 3 weeks after Thanksgiving?
Yeah, it's 2 weeks till Thanksgiving. So I think it is.
Really?
Next week.
Are you sure?
Well, tomorrow's the 10th.
Do we have the whole week of Thanksgiving now?
Yeah.
I think we do, yeah.
Yeah.
Tomorrow's the 10th, so next week on Wednesday, the 17th.
Yeah, no, we have 2 weeks
Okay, yeah, you're right.
before Thanksgiving.
That's good news. And then is it 2 weeks after Thanksgiving or 3? I thought it was only 2.
It's probably like 3.
It could be 2.5. Could just start out in not like that. Thursday.
Let's not do that. If we're gonna take some days off, we just take the week off. I'll check it out. All right. What's the greatest common factor? Let's start there. What can we take out? What can we divide out of both of these terms? 2. I heard a. What else? A to the second, because 3 and 2, so 2 is smaller. All right. And then b to the. Just b, and then z to the third. All right, let's go shopping. What are we left with when we take this, when we divide this out of that?
We have 2.
Yep, and if you need to, guys, do this. 2a squared bz cubed. 2a squared bz cubed. So what are you left with? 4 divided by 2 is 2. And then what? A to the 1 or just A? Uh-huh. And then the Z's cancel, right? So see how you could, if you do it like this, then you can see all the subtraction of the exponents. You can see the division of the big numbers. That'll be easy. So what about here? What do you get? What happens with the 2? Cancels. Okay, so it's 1. 2 divided by 2 is 1. What's a squared divided by a squared? That cancels. What's b divided by b?
1.
And what's z to the 4th divided by z cubed? All right, is that what you guys got? Nice. All right, so that's it. This is where math starts to feel weird, because I love having an answer like 7 or 4, or, you know, I'll even take a fraction every once in a while. But it's weird that this is the answer. Like, are we done? It feels like we're very unproductive. Like we went backwards. Well, you did. Because factoring is backwards thinking. A lot of algebra is backwards thinking. So a lot of, it's like Jeopardy. Did you guys hear that Alex Trebek died? He was like the host of Jeopardy. Like dun, 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 dun.
Yeah,
Anyway, Jeopardy, they give you the answer and you have to come up with the question. Well, that's what a lot of algebra is. Okay. we're going to just do one more example, and then we're going to move on to the next part of this. So here's one more example. And we'll do this one together, because this is going to be on one of your tests coming up, probably the next one. And so I don't want you to make this mistake that I see over half the students make when they do this test. Okay? Well, the problem isn't different than this. We still have to find the greatest common factor. So what's the greatest common factor? What about numerically? Is there a greatest common factor numerically? The big numbers? Well, 3 doesn't go into that. It's just 1. So there's no numerical greatest common factor. So then we're just looking at letters. Okay? So what letters? What's my literal greatest common factor? M squared.
X is not.
Yeah, X isn't in both, so X is out of the question.
And Y.
And then just Y. Okay? Everybody see that? Because you're just looking at the smallest exponent of each variable. Well, this variable of X has an exponent of 1. This doesn't even have an X. So the smallest X variable is 0, which is 1, which you don't have to write. Okay? So whenever you get confused, you can always go back to, well, I'm still looking for what both of these have in common. Okay? They don't have an X in common. All right? They have some M's in common and an Y in common. So that's all you can include in the greatest common factor. All right. Well, so you'll get half points for getting the greatest common factor. The other half comes when you actually factor it out. So what are you left with when you divide this out of both?
You get 3
3xy. And then what about here?
It's a 1.
There. That's the right answer. Okay? Most people just say, oh, that cancels out completely. Right? Well, what happens when it cancels out completely? What are you left with? Not 0. So you're left with 1. So remember, if it helps, do this. It's still dividing. You're not subtracting. It's still dividing. So when you have m squared y divided by m squared y, yes, those cancel, but they cancel to 1. The reason why we didn't have to write a 1 here is because we are still left with something. I mean, technically, 2 over 2 makes a 1. A squared over a squared makes a 1. B over b makes a 1, and you're left with 1 times 1 times 1 times z. Okay, but you don't need those 1s. So that's why we just kind of ignored it. And then you're just left with this guy. That's your only math. All right, well this, you need a 1. So don't forget that 1. The most common mistake on your next test will be to forget that 1. Don't make that common mistake. Go against the odds. Okay? All right, the next part of this lesson is we're going to talk about canceling. Now we've talked about canceling when you multiply fractions, right? You can cross cancel. The reason why you can do that is because something is being multiplied and then something is being divided. So inverse operation or opposite operations cancel each other. When I say 6 plus 4,782 plus 0 minus 4,782, what's your answer? Do you have to add 4,782 and then subtract it? No, because it cancels itself out, right? When you add the same thing and then subtract that same thing, it cancels it out. Well, what's 6 times pi divided by pi?
6.
6. When you multiply it by pi and you divide by pi, it cancels. That's nice. Okay? So that's what happens when we solve equations too. And that's like the best part of solving equations is canceling. So for example, 4x equals 20. How do you get x by itself? Well, 4 is being multiplied, so do the opposite operation so we can cancel it. If you multiply x times 4 and then divide it by 4, it's like the 4 never existed. So x equals 5. Okay. Now, here is another very common mistake. When I say x plus 4 divided by 4, can I cancel those 4s? No, you can't. All right. One of my math teacher colleagues in Arvada, she has a poster on the board, and there's a little line through that, and then the poster is a picture of a kitty. It says every time a student cancels those 4s, a kitty dies somewhere in the world. So don't let that kitty die. That's what the poster says. It's not my poster. But anyway, you can't, because these are not opposite operations, are they? Division is not the opposite of addition. You can't add 4 then divide by 4 and get back to x, right? That doesn't work. So this is just already simplified. It's already reduced. Okay? So you can't reduce that anymore. It's reduced to lowest terms. But, big but, if you had something like this, 4x plus 1 divided by 4, is something being multiplied by 4 and then divided by 4?
Yeah.
Yeah, so this, yes, you can cancel the 4s. And then you're left with a nice x plus 1, and you're done. Okay? Do you see the difference between those two problems? Okay? This is factored. Factors are multiplied by each other, right? That's what it means to factor. You say, what times what equals this? Well, if this is being multiplied by 4 and then divided by 4, you can cancel it. Okay? All right, so let's try some examples. Let's simplify this. Okay? You can write that example down and then write the simplified version of that. So the directions will say simplify. What do you got? Yeah. So these just cancel, so you can write this down in your notes and just put a little line through those 4s, and you're left with a minus 3. Boom, you're done. All right, what about this? Three. That's it. So this is a factor, right? It's a chubby factor, right? But it's still a factor. It doesn't look like a normal factor. It's a little wider. Don't judge that factor. Okay? But this factor is also down here in its entirety. Okay? This x minus 2 is the only thing down there. So if it helps and you want to put parentheses around that, you can, to make yourself feel better about canceling those two things. But this whole thing is a factor. There's 2 factors on top, 3 and x minus 2. X minus 2 cancels completely, and you're left with 3. That's beautiful. I love it when that happens. When you cancel a bunch of stuff and you're just left with 3. All right, so this is where it gets a little bit more challenging, not too much. 3p plus 3 all over 3. Can I cancel those 3s? What's that? Oh, what did you say?
I heard someone else say it.
Say what?
P
It's not p plus 3. Now here's why. And it looks like, well, this is being multiplied by 3 and then divided by 3. No. It's being multiplied by 3 and then you add something and then divided by 3. So the cancellation is not 3 times something divided by 3. It's 3 times something plus something else, even though that's 3 divided by 3. So, well, when in doubt, factor it out. How does this factor? What's the greatest common factor here? What goes into both 3p and 3? 3. When you take it out, what are you left with? P plus 1. Now can I cancel those? Yes. Good. All right, so when in doubt, factor it out. So if you see this, like, oh, that can be factored to 3 times p plus 1, and then I can cancel the 3's. So see how this is now 3 times something divided by 3. So now I can cancel those 3's. But this was not. This was stuck in this addition problem. This multiplication was stuck in this addition problem. Okay, so I could not cancel that 3. All right, let's try something else here. Let's try 3x minus 9x squared all over 3x. Okay, when in doubt, factor it out. How do you factor that top? What goes into both? 3x. That's right, 3 and x go into both. What are you left with? 1. Don't forget that 1. Remember, when you divide a 3x out of that first term, it's just 1. Minus, well, it's the 3, but x is right, 3x. Okay, all over 3x, what cancels? The 3x. Can you cancel that 3x? Nope. So you're just left with this. That's your answer, 1 minus 3x. Okay, now, if this is confusing to you, that's okay. Let it be confusing. Let it be challenging. When in doubt, factor out, but there's another way to do this. This is kind of like 3, you're dividing both of these by 3. So what happens when you divide both of these by 3? So 3p over 3 plus 3 over 3. This is kind of like the distributive property of division. So you're not just dividing one of these by 3, you're dividing the whole thing by 3. So what are you left with? You're left with p plus 1. Same answer. Okay?
I was actually shocked that worked. I was like, whoa!
All right, so you can do the same thing here too. Look, let's make 2 division problems out of this. What's 3x divided by 3x? 1. And then what's 9x squared divided by 3x? Right, so 1 minus 3x. Same answer. Okay? There's 2 different ways. I think it's great to just practice both ways, but when it comes to a test, do what feels good. Do what feels strong. Okay? You can check it with the other way that maybe doesn't feel as strong. Okay? All right, one more and then we'll move on to lesson 36. Okay, see if you can do this one by yourself. Now this one's a little different. You might not be able to do it the green way here, the second way. Okay? But you can try if you want. Here's example 9. 5x minus 25x squared all divided by 5xy. So see if you can do that one by yourself. I think I lost my pen cap. Get it. It's not a very strong pen cap.
Beyond the Kleenex box.
Yes, it is. Good job. I'm gonna give you a problem set point.
Oh, I thought you said like problem set.
Not a free problem set, but
Well, no, I
good problem set point.
like extra homework is what I was saying.
Well done.
Wait, you were. No, thank you.
So now you have 3 points. So if you get 2 more, you get a free problem set. You guys need more time? All right, when in doubt, factor out. What goes into both 5x and 25x squared? Okay, so if I take a 5x out of both of those, what am I left with on top? 1 minus 5x. Good. All over 5xy, what cancels? Just the 5 and the x. So you're left with that y downstairs. So then you're just left with 1 minus 5x all over y. Is that what you guys got? Anybody get that?
I did.
All right, good job. Let's try it the other way. Let's try the 2 division problems. So we're gonna make a division problem out of this, 5x minus 5xy minus 25x squared over 5xy. Okay, so far so good? So what cancels here? The 5x, and what are you left with? A y on the bottom, so how do you say just a y on the bottom? 1 over y, right? So if everything cancels on top, you still need a 1 there, 1 over y minus, what? How does this work? 5x over y. Is that the same thing as that?
No, kind of.
Yeah, if these are fractions with common denominators. So you just add the numerators, 1 minus 5x all over y, and that's the same thing. So if you get this answer on a test, or this answer, I'll mark them both right, okay? But see how they look a little different, so it might be a little confusing. But it's still the same answer. But technically, you could make this into one fraction because they have the same denominator, so you can combine them together, okay? All right, so that's lesson 35. That was kind of a lot. Factoring, the reverse distributive property, and then canceling, that's kind of a lot. But luckily, you get to do some homework to practice this. You guys okay with this? You think you can handle it?
Yeah.
Okay.
Flack!